A 9380 relay, what would be the purpose or purposes of the relay, and what would the relay control, etc.? Relay is just a simple way to put it. It's a way to turn on and off a particular circuit, perhaps, and I'm not sure if this is the correct um, overall view, but basically what it does, it turns on and off a circuit. Say if one goes over to their light switch and flips the light switch, it either turns it on or turns it off. So hypothetically, this happens. Okay, with a relay, the relay can take low voltage and actually turn it on and off with the say the voltage. Say if we had a say the thermostat wire hooked up here. Say if this was was a fan relay and we had a say a green thermostat wire here and a blue for a common here, and we energized it. Say for instance somebody turned the fan on. Okay, these contacts up here would control high voltage. So this particular contact here, I'm not certain if this is I think this is a normally open on this one and this one. Don't hold me to this, but let's just say we energize energize this with the for a call for fan. So we have a green and a blue, green being fan, blue being the common, and we have a wire feeding here and a wire feeding here, and it's picking up electricity, say from the maybe the contactor or wherever, and this particular electricity is broken between this point, because between here and here, if it is open, then there's no way for the electricity, unless this thing were welded shut, that is, or something. I'm not sure if that would even I'm not sure if that would affect it, but let's just say we got it open here. So we'll consider this, go back to the analogy with the light switch. Say if it's open, the light switch would be in the off position, perhaps. Okay, say for instance, then the thermostat calls for fan and it energizes this. So then this contact, this closes this low voltage on these two terminals here, close these terminals here, and one has power, and then this power here is able to jump over here, and say downstream we have a blower motor. So now we have electricity flowing from here to here, and now we've bridged this circuit. So when this circuit is bridged, we have electricity. But say hypothetically, if one goes to the thermostat and turns it to the off position and it's not working, it's not sending a signal or whatever, this de-energizes. So now this circuit here that has closed, once this is energized, may open. So when it opens, the electricity is going to stop on one particular part, and it's not going to feed, say for instance, it's not going to feed all the way down back to the blower motor here. So again, let's recap what's going on. We have a relay, and a relay is a way to turn an electrical circuit perhaps on and off. Again, a relay may help turn a circuit on and off. So it may be energized on the 24 volt side. Say for instance, if this were a fan relay, it may have a green, it may have a blue, green being fan, blue being common. This say this is normally open here, and then this becomes energized. Then you have a wire going this way, a wire going this way, and the load side over here, whatever it's feeding, say the blower motor, say this is hypothetically open here, and then once it's energized, you go here, this circuit closes. Now the electricity is able to freely flow from the source to the load side. From the, I don't know if from the line side to the load side would be an accurate depiction, but so again, let's rehash. We have a 90-380 relay. So we have the low voltage, which is energized. When the low voltage is energized, the 24 volts, this would be a NO, normally open relay here, hypothetically. Now it's energized, so this closes. Once this closes, electricity comes from the line side through here, and it makes a bridge here and goes to this side, say to the blower motor here, and the blower motor is able to turn on. So a 90-380 relay. Thank you for watching.